going to do some problems from section 4.1 in calculus. Once you know about the chain rule and all your other derivative rules, this sure is pretty easy stuff, I think. You just really need to be careful about popping out your dy dx's. So let's do it. Let's find some dy dx by implicit differentiation. I think I probably said in the notes why it's called implicit differentiation. And what's the opposite of implicit? I guess explicit is, right? So when you have y equals function of x, that is a function that is given explicitly in terms of x. Explicitly. Get it? So x is the right variable. So when I take the derivative here, that's 2x. It just is the derivative of x squared really is 2x. Nothing else to say about it. But the derivative of 2y, y isn't the right variable. It's kind of like almost like that's inside, and the derivative of what's inside is that. So, of course, derivative of 100 is just 0. So here, dy dx would be equal to 2's cancel, so it's minus x over y. Number 13. There's going to be a little bit of a, like, how much do you want to simplify kind of thing going on with these, but you do have to get it into dy dx equals, so I think we're kind of forced a little bit to do some simplifying. Let's see how it goes. So here, I always like to just underline the two things that that are going to be the two parts of my product rule when I have that, so I can keep them straight, especially when there's a constant like that 3. I'm going to bundle that 3 with the x and call that the first. All right, so here, derivative of the first times the second plus the first times the derivative of the second. The derivative of y is dy dx. Plus the derivative of the first times the second plus the first times the derivative of the second. Easiest mistake to make is to leave that off. Derivative of x is 1, derivative of 3 is 0. Okay, now I do have to do a little bit of simplifying here. So it looks like I've got these two pieces here of, when I say pieces, I mean like monomials, or like chunks of things that are bound together by multiplication and division, and chunks that are separated by addition and subtraction. So these ones I will lump together, and I'm going to go ahead and factor the dy dx off of them, leaving behind x squared plus 9xy squared. And then I'm going to move everything else, which is 1, 2, 3 pieces, to the other side. I'll put this one first since it's positive, and that appeals more to my obsessive compulsive disorder way of wanting things to look. And then finally, I wrote this kind of high up here because I was anticipating dividing by that, but I think I'll leave that for just one more step. How many corners can you cut to streamline your work? Well, I don't know. How many can you without making a mistake? 15, I've got, I don't like the way this is written. This is x to the negative 1/2 plus y to the negative 1/2. That is more calculus-friendly way of writing that. So let's see, that's negative 1/2 x to the negative 3/2 minus 1/2 y to the negative 3/2 dy dx equals 0. So after I move stuff around a little bit, do a little bit of algebra, cut some corners, it looks like I'm going to have on the top, I'm going to have x to the negative 3/2, which really means that, So I think it's that. Once you deal with the negative signs, you don't want to have like x to the negative power on the bottom of a fraction. That just doesn't make any sense to write that way. So I think I got that okay. Everything's in the right place. Maybe I should open up the answer key and make sure I'm getting the right answers for you. You have the back of your book, of course, to check. So, quick check of that. Number 15 looks good. All right, number 17. Sine of x squared y squared is equal to x. All right, so that's supposed to be x there, sorry. Sometimes my brain automatically takes the derivative before I even am ready to do that. The derivative of sine of whatever is cosine of whatever times the derivative of what's inside. The derivative of what's inside is the derivative of the first times the second plus the first times the derivative of the second equals 1. All right, so let's see. I need to solve for dy dx, so I guess the first thing I need to do is divide this over to the other side. Now, cosine, 1 over cosine is the same as secant, so I think I'll take advantage of that mathematical truth and write that like that. So that's 1 divided by this. And then this doesn't have any dy dx attached, so I'm going to subtract that over. I apologize if this is too much in one step. This is, I know you like to be efficient, but not at the cost of comprehensibility or careless mistakes. So you have to decide what works for you. But surely, if you slow down and write out a couple more steps, you can get to the same spot. I know it. All right, so that's that. Probably this should be written as 2x squared y, because that's how civilized people do that. All right, quick peek in the answer key. They didn't do the secant thing, so their answer looks a little different than mine, but that is right. I like mine answer a little bit better there, in fact. Number 19. Tangent cubed. Okay, I'm going to go ahead and write that in my more calculus-friendly notation, like that. So that's suggesting to me that we're going to have a couple layers of chain rule here. So let's see, the derivative of anything cubed is 3 times that anything squared times the derivative of what's inside. The derivative of tangent whatever is secant squared whatever. And then times the derivative of what's inside there. The derivative of xy squared is the derivative of the first times the second plus the first times the derivative of the second plus derivative of y is just dy dx. And then equals 1. All right, so it looks like all of this stuff needs to be divided over to the other side. And let's see, so I'm going to have a 1/3, maybe a 3 on the bottom there, and then tangent upside down is cotangent. You can go back to this notation because I'm done with the calculus portion of this problem, and then that upside down goes back to cosine. Okay, so that's all this stuff divided over to the other side, which would leave this. And then these two pieces have dy dx on them, but this one does not. So I'm going to minus y squared. Just be careful you don't put it on top of that, because that doesn't have anything to do with that dividing by 3. That already happened. And then here I've got dy dx that's attached to two different chunks of stuff. This one 2xy, and then this one I just plus 1. Right? And so I get dy dx is equal to this whole thing over this. Now the only problem there, and it's not a huge problem, is that you're not really supposed to have, if I'm dividing by this, I guess we could do it like, oh yeah, that'll work fine. Never mind. There's no problem here. Let's see. I'm curious to see here how this compares what I did here to what the book has. So I'm going to divide. My 3 is still there, and I'm dividing by this. So I don't really see any advantage to distributing that 3. Minus y squared, but this y squared also has to get divided by that. We're dividing the whole thing. Right? That's what I'm going to leave my answer like. Let's see what they did. Yeah, so they got a common denominator, and what else did they do? Just in case you're curious. Oh, I'm looking at the wrong one. They left it in terms of tangents and secants, and they got a common denominator. So theirs looks like a big horrific mess. But the point of these problems, many, many times in math classes, you have come up against a situation where, like when you're just learning something, like this, for example, the problems get pretty messy. Like in the long term, things are not typically going to be like this. You need to know how to do implicit differentiation, and when that's all we're doing, that's all we're focusing on, then those problems will tend to get a little messy sometimes. But that's okay, we can handle that. Alright, so 21, I'm going to find the second derivative here. So this is an important skill. I don't remember if I covered this in the notes or not. So if I didn't, and you see this first problem done, and you're like, oh, okay, I think I get it now, that would be the time when you should pause and try 23 and 25 yourself. Okay, so let's see. How do you find the second derivative? Well, we have to find the first derivative first. We need to get to this point, dy dx equals thing, and then take the derivative of that. So let's see. Derivative of 2x squared is 4x, end of story. Derivative of 3y squared is minus 6y dy dx equals derivative 4 is 0. Alright, so dy dx is equal to, when I move that over here, 2x over 3y. After we do a little bit of a reduction. Alright, that looks good. And then to find the second derivative, well, second derivative is the derivative of the derivative. So the derivative of dy dx is second derivative. And then on this side, looks like I've got some quotient rule. Low, d high, the derivative of 2x really is just 2, minus high, d low, over low, low. Okay, and you could think to yourself, okay, I'm done, that's it. Well, you're not really done because we need to give an answer in terms of x and y. And this is dy dx. You might say, well, there's an x and a y in it, but there's not supposed to be any d's in there. You're not supposed to have your answer in terms of the derivative of other layers of derivative, if it can be avoided. And here it can, because I know what dy dx is. It's this. So I need to substitute there. So 6y minus 6x times 2x over 3y over 9y squared. And you're not allowed to have a fraction inside of another fraction. That's called a complex fraction, and it's really to be avoided if at all possible. In fact, you could say that there's a rule against that, and when you break a rule, that is called an infraction, so that you could say that this is a fraction infraction. Come on, that's so good. I made that up. Sorry, that might be in some other video somewhere. That's like the best joke I ever made up in my life. So, trying to get maximum mileage out of it. So let's see, those cancel out. I get minus 4x squared over y. So what am I going to do here? I don't want that y to be in the denominator here. The 3 took care of itself, but I need to multiply the top and bottom of this by y. So that'll turn this into 6y squared. Here it'll get rid of that denominator, and here it will turn that into y cubed. Okay. So that's all fine, and then you look in the back of the book, and you're like, okay, the back of the book says that it's negative 8 over 9y cubed. Like, what the heck? Okay, so let me just show you what happened there. This happens sometimes with these, I don't know if you know what this is. This is a hyperbola. So it happens with conic sections, especially things like this, where upon taking the second derivative, we actually got a version of this. If you look carefully at this, this right here could be written negative 2 times 2x squared, because, I mean, that is negative 4x squared, right? Minus 3y squared. Minus times minus is positive, like that, over 9y cubed. And of course, 2x squared minus 3y squared is 4. So that's just 4, and that's how they got that. Is this wrong? No, this is absolutely correct. Is it okay if you miss that? Yeah, sure. Don't fret about that, even for a minute. So number 23. One more second, or maybe, oh, just kidding, it's not one more, it's 2 more second derivatives, and then we're done. X cubed y cubed minus 4 equals 0. So product rule, I got the derivative of the first times the second plus the first times the derivative of the second. Every time you take the derivative of something with a y in it, pop one of those out. That's derivative, that's 0, same here. Okay, so it looks like dy dx is equal to, when I move this to the other side, I get minus 3x squared y cubed over 3x cubed y squared, which is minus, what do we have left on the top? A y, and then at the bottom there's an x. Okay, I want the second derivative here, so let's see, where shall I put this minus sign? I guess I'll put it with the y on the top. So low d high minus high, d low is just 1, over low, low. Right? And then a similar kind of situation here, except that, let's see, this is minus, so it looks like I'm going to have x times y over x minus dy dx plus y for x squared, and that is just 2y over x squared. That's the second derivative. Last one. Y plus sine y equals x. Derivative of y is dy dx. Derivative of sine y, sorry, don't know why I did that. Sine y is cosine y times dy dx equals 1. Okay, so solving here, that means dy dx, factoring that off of this, and then dividing that 1 plus cosine y over here. It'll look like that. Hey, is that just the same as 1 divided by 1 is 1 plus secant of y? Is that the same as that? No. You know why? That is bad algebra. You can't do that. I'm not going to say anything more about that. Just got to be careful. You guys are the pros here, so we're learning how to do calculus. You know, you don't want to fall down on your face in a pile of algebra. So, second derivative. Well, let's see. I could use the quotient rule here, or I could say, you know what? If I have a choice between quotient rule and chain rule, maybe I'll just kind of imagine it like that. So that's minus 1 times 1 plus cosine y to the minus 2 times the derivative of what's inside. The derivative of cosine whatever is minus sine of whatever, and the whatever was a y, so dy dx pops out. That is a little multiplication dot there. Alright, so I got a couple minus signs there that will take care of each other. And then on the bottom, I've got a 1 plus cosine y squared. And on the top, I've got a sine y. And then I've got a dy dx, which is 1 over 1 plus cosine y. So, I mean, got to simplify that, right? That's just sine y over, I've got actually 3 of these. So that's what that's looking like. And I think we're looking like we're done with that homework assignment.